Hello, hello, my brilliant students. Welcome to my Algebra 2 Unit 1B test review. So this is to help you guys get ready for the test and review all the stuff that we've been learning over the last, 4 weeks? Something like that, maybe 3 weeks. All right. So you should have this document in front of you. We're going to talk about all of these things. Hopefully you've already tried this and you're not just doing it for the first time. But let's see, are you doing this in class? Yeah, I guess this is an in-class thing. Now, this will be posted so you can watch it at any point. If you're absent, you can watch it. So, this is asking to determine if the following functions are one-to-one, and explain how you know. So in order for something to be one-to-one, it has to pass two tests. What are those two tests that it has to pass? Yes, they are the vertical line test and the horizontal line test. So in order to pass, we have to say, okay, well, does this pass the vertical line test? Does it pass the horizontal line test? And I'd say yes. It would be one-to-one. Now, I think there might be some controversy because of these asymptotes. We're going to say it's one-to-one, that it never actually reaches the asymptote. In this case, however, if I do the vertical line test, we're good, right? Oh, I'm sorry, I can't get my pen to be a vertical line. But if we go this way, we never hit two parts of the function at one time. But if I do the horizontal line test, I hit twice here, or I hit twice here. So it fails the horizontal line test. So this is not one-to-one because it fails the horizontal line test. So the horizontal line test tells me that the inverse of this function would not be a function. All right, the next two are asking us to write the equation of the following. So this is what you did, let's see, on Thursday and Friday in class. So we're going to go over and up. Let's identify the vertex. -2, 1, 2, 3, 4, 5. -2, 5. And then we can write our equation. We know this is an absolute value. We need to say, okay, well, let's see, y equals, I'm going to get it ready, absolute value. On the inside is our horizontal movement, right? So x, not -2, but +2, because we're doing the opposite. And then we're going up 5. That tells me up 5. Now something else happened. A couple things more happened. We need to look at what was the stretch that occurred. It looks like down 3 over 1, down 3 over 1. In this case, it is the slope, but I don't want you to get in the habit of calling it slope. The negative really was a reflection. So this reflected over the x-axis, and it became that. And then it stretched by a factor of 3. So instead of going down 1 over 1, it went down 3 over 1. So this is a reflection, and this is a stretch by a factor of 3. Okay? Over here, you should get -3, let's see. I'm going to say f of x, not y. Get you guys used to that. So maybe we want to identify this. We need to identify our parent function. Square root of x, right? And we shifted -3, -2. Sorry, -3, -2. So we want to go on the inside and on the outside. Opposite on the inside. And was there any reflection? Is it now flipped upside down? No, it's not reflected over the x, it's not reflected over the y. And the dimensions, if I go over 1 square, the square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. So there was no stretch or compress, so that would be our answer. All right, I hope you guys are checking your work. Explain the transformation. So we want to identify what the transformations are. There are 1, 2, 3, 4 different things. This is saying, well, here's the parent function. This is what we started off as, and this is what we became. So here we have reflect over the x-axis. Here we have a stretch. Maybe I'll use color coding. I like color coding. Stretch by a factor of, that's that baffle thing, stretch by a factor of 3. Right here, let's say green, -2. Remember, it's the opposite when it's on the inside. So this is a horizontal translation or shift. How many units? 2 units. And I need to say the direction to the right. And then the last one, +5, would be a vertical translation or vertical shift. 5 units up. Woo, that's a lot of writing. All right. Try the next one, and then go ahead and hit pause. Try the next one, make sure you're good with it, and then we will, the answers will just pop up. Okay, so hit pause. All right, so that's what you should have gotten. Notice this is a stretch when it's a number between, I'm sorry, when your A value is greater than 1, and it's a compression when your A value is between 0 and 1. The compression or stretch has nothing to do with this reflection. I mean, they are two completely separate things happening here. The negative says, well, this reflects over the x-axis, and this one does not reflect over the x-axis. Okay? So it's really the value of A, not the positive or negativeness of it that makes it a stretch or compress. It's the value. All right. What else do we have? Be sure to state the domain restrictions when applied. So we're going to find and simplify when we do all these operations. Okay, so again, I really want you guys trying these before you watch this. So I'm going to get them all set up, and then we can check and see if we got the same answer. So try them, see what you think, and then check your answer. All right, so go ahead and hit pause. The first one should look like this. Your x squared doesn't have anything that has a like term. These two combine to give you +1, and these two combine to give you -3. All right. On the next one, you want to be careful and make sure that that negative distributes to all three pieces, becomes -x squared plus 2x plus 5. And then you can add your like terms just like you did on the last one. And that's what you should have gotten. All right. The next one, we're going to multiply a binomial times a trinomial. So I need a little space for that. I'm going to shift this picture over a bit. Okay. So here I've decided to set up a box for my binomial and my trinomial, being really careful that the -5 and the -2x, that anything that's negative stay with the number to the right of it. All right. I want to be careful that my power increases. X times x squared gives me x cubed. Here I multiply -6, x times x gives me x squared. Here we get -15x. I want to be careful. 2 times x squared would be 2x squared. -4x and -10. Now we want to combine our like terms. So if we look at the diagonals, oftentimes they are like terms. So we have 3x squared. Now we're going to add everything up that's in here. So 3x cubed is going to be plus or minus? Minus, because I'm adding these up and I get -4 minus 4x squared. These two added together give me minus 19x and then minus 10. And that would be the final answer. All right, let's try some more. So this is saying something slightly different. This is saying let's evaluate f of -2. So it's basically saying instead, in place of x here, this was f of x, but in place of x, let's plug in -2. But in the g function, this is g of x. Well, in the g function, x is 4. So here we have x's, 2 different values. Well, but that's okay because it's in 2 different functions. So in here, I'm going to put a -2. -2 times 3 plus 2. So -6 plus 2, that would be -4. And we're going to add that to g of 4. So let's plug a 4 in over here. G of 4 equals 4 squared minus 2 times 4. 2 times 4 is 8, and 4 squared is 16. Minus 8 would be 8, minus 5. 8 minus 5 would be 3. So we end up with negative 4 plus 3 is a negative 1. So we just have to kind of work step by step. Find this, find that, and then add them together. All right, let's try our g divided by f. So let's erase this so we can actually see our g and f. There we go, that's a little better. Okay, so we're taking our g function and we're dividing it by our f. Now, I could see if I can factor this. 1 times 5. We haven't talked much about factoring. You did in Algebra 1 a bit. But this is not factorable. There's nothing that we have in common that I could simplify. So I really just need to make sure that the denominator, 3x plus 2, is never going to equal 0. So we want to subtract 2. Right? Subtract 2 from both sides. And I get 3x is not allowed to equal negative 2. And then divide both sides by 3. So our x is never allowed to equal negative 2/3. So my answer is this fraction and my restriction. X is not allowed to equal negative 2/3. We need to have that whole piece as our answer. Okay? The last one is saying first evaluate f of negative 3. So let's plug f of negative 3. Use our f function up there, which is 3 times negative 3. Plus 2. So everywhere I saw an x, I plugged in a negative 3. All right, so we have negative 9 plus 2 is negative 7. So I just found that f of negative 3 is negative 7. I can replace f of negative 3 with something that's equal to f of negative 3, so I can find g of negative 7 now. So let's plug negative 7 into g. Oh, this is exciting. All right, negative 7 squared becomes 49. Minus 2 times negative 7, so that becomes plus 14, and then minus 5. Let's do this first. That would be plus 9. 49 plus 9, right? I added these two together. 49 plus 9 would be 9 and 9 is 18, so 58. Woo! So g of f of negative 3 is 58. That is what I get. Hopefully that's what you got. All right. Find the inverse of each function below. All right, so let's do one together just to refresh your memory. What is an inverse? Oh yeah, when I see inverse, I want to be thinking x and y switch places. So here's my x, here's my y. Remember, f of x is just y. So I want to put my x on this side and my y right there. So I'm switching x and y. All right, now we want to solve for y. So we're going to subtract 3 from both sides, x minus 3. And then we need to divide both sides by 2. Now, I want to make sure that you're comfortable rewriting this in slope-intercept form. So this 2 applies to both the x and the negative 3. So really, that would be x over 2, or 1/2 x, right? There's a 1 here, so 1/2 x minus 3/2. We need to practice that and make sure we're okay with that. Now, what did I just find? Oh, I didn't find y. So can we erase that? No, it's not going to want to erase, is it? Maybe I can pull it away. Ungroup. Pull away. No, okay, never mind. It's taking too much effort. Let's try an eraser. There we go. All right. So equals f, right? F, but I've found the inverse, and how we show that is f inverse of x with that little negative 1. All right. So now some of my students in the past have asked, well, what about this? What if I got this as my answer? It could be 1/2 x or x over 2. Does it matter if that's over there and that's over there? No, it doesn't matter. It's fine if you put f of x on this side. It's like saying $1 equals 4 quarters, or 4 quarters equals $1. It doesn't really matter which one you put on which side. They're still equal. All right, so I want you to try these and check back to see if you got them, right? X and y switch places, and then solve for y. All right, go ahead and hit pause. All right, hopefully your answers look something like this. 4x plus 1 equals g inverse of x, or g inverse of x equals 4x plus 1. And over here you should get the opposite of x plus 3 halves. Right here it looked kind of funny, but a negative divided by a negative would be a positive 3 halves, and 2 over 2, one of them negative, would end up as a negative 1. All right, so hopefully that makes sense. If you have questions, you could raise your hand and Miss Russo could call on you guys and you can help each other answer your questions if you have them. All right. All right, use composition. Now this is telling me what to use right here. Use composition. Composition is like f of g of x, right? We're weaving one function into the other. We're going to use that to verify whether or not g and f are inverses. And in order to know that f and g are inverses, this must be true. F of g of x must equal g of f of x. It's like a tongue twister. G of f of x must equal what value? Is it just that they have to be the same? Or they have to be equal to something in particular? Yes, they have to also equal x. Okay, so this is what we're looking for. And if this is true, then they are inverses. If it's not true, then they're not inverses. So let's check this one. F of g. So I'm going to start with f of g. So I'm going to plug my g function into my f function. So I take my f function, I write a big blank because I need to have space for all of this. So I'm going to plug my g into my f. Negative x minus 3 over negative 2. Aha! Okay, when I multiply these together, negative 2 in the numerator and negative 2 in the denominator simplify. And I end up with negative x minus 3 minus 3. Ah, this doesn't equal x. Minus 6, that is definitely not x. So I'm feeling like these are not inverses. I might want to double check and just plug f into g just in case I made a mathematical error there. So let's say g of f and say g of f. So we're going to plug f into g. The opposite of that, minus 3 over negative 2. And we're going to plug negative 2x minus 3 in. So now the negative distributes, and we get positive 2x plus 3 minus 3 over negative 2. Aha! I see right here I can simplify. Those cross off. Ah! And we get 2x over negative 2, which is just a negative 1x. Is that x? No. All right. So they both did not give me x. So that tells me f and g are not inverses. So I need to state that f and g are not inverses. Inverses. And I could say, well, because f of g of x did not equal g of f of x, and it did not equal x. So all of this was not true. So they are not inverses. Whoop. All right. You guys try this one on your own, and then double check and make sure if we agree. All right, go ahead and hit pause. Thank you. All right, this is what I got so far. F of g of x does equal x, and g of f of x, equals this. Be careful. Make sure you're simplifying. 12 divided by 4 is 3. All right. Plus 3 minus 3. Looky there. Is x. Okay, so because we got x and because they are equal, we can say they are inverses. F and g are inverses because f of g of x equals g of f of x equals x. All right. What else do we have? I think there's some transformations, or are we done? Oh, yes, 2 more transformations. All right. Parent function. Parent function is g of x. Oh, it wouldn't be g of x because that's what we did to get, that's our transform function. So let's say our original function maybe was f of x. And if we hide all of these, if we cover up all of these transformations, we'll see, oh, there's my parent function, square root of x. Let's go and erase all this now. Whew. Don't need that. Okay. So, the transformations, I want to identify what happened. Well, it looks like it went a vertical shift up 3 units. And it also had a horizontal shift 2 units to the, think about it, am I going to the left? No, I'm going to the right, opposite. Okay, so 2 units right. All right, were there any stretch or compress? Any reflection over the x or the y? Nope. Okay, so let's go ahead and graph it, and then we'll talk about domain and range so we can see that better. So it looks like this, in this case, it wouldn't be called the vertex, but the point that we're starting our square root function at, this point right here, is going to be at +2, +3. So I'm going to go 2, 3. That's my starting point. And because my dimensions didn't change at all, I'm going to go over 1, up 1, over 4, up 2. Another way of doing this, which is probably the more accurate way, the more structured way, would be first setting up our parent function values. So use this parent function and say, okay, can I put a negative? No, because the square root of negative is a non-real answer. So I can start with 0 and 1, and some really good easy numbers to choose would be like 4 and 9, because I know the square root of 4, and I know the square root of 4 is 2, square root of 9 is 3, and the square root of 1, what times what is 1? Ah, 1. Okay, so those would be my parent function values. And then these transformations get performed to this graph. The y, because it's a, the k value right here, because it's a vertical shift up 3 units, it's affecting my y, right? This is my y-axis. So we're going to go y plus 3. So I add 3 to each of those. 0 plus 3, 1 plus 3. Oh, sorry, 1 plus 3 is 4. 2 plus 3, 3 plus 3. All right, and then over here on the x, remember we're doing the opposite. So we're not saying x minus 2. This is really key. We have to do x plus 2. So we're going to add 2 to each of these. 0 plus 2, 1 plus 2, 4 plus 2 is 6, and 9 plus 2 is 11. So now we're going to ignore this, and these are the new values of our graph. So 2, 3, 2, 3, right? That's 1 point. 3, 4. 3, 4, and then 6, 5, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 5. So that would be another way of plotting the points, and 11, 6 is off the graph. I can't quite see that, so I'm just going to leave that one there. The domain and range. Which x values and which y values are we talking about here? X's that are greater than or equal to 2, and y values that are greater than or equal to 3. All right, you guys try the other one before you watch the video. Try that one and then check your answers. And I think that's it. Is that it? Oh, that's it. All right. And then I get to see you tomorrow and we take our test. Yay. So that means I'm flying home right now. Well, if you're watching this on Monday, I'm flying home. All right. I'll see you guys tomorrow. Hit pause and then hit play and you'll get the answers. Alright, I just started doing this and I realized I must have made a mistake here. So I did my table, I plotted my points, and I'm like, wait a second, there's not a consistent slope here. So if I rise 1, run 1, this is not a quadratic, this is not a parabola, this is an absolute value. So something's wrong here. Let's check my points. So this point I think might be incorrect. Let's see, my vertex should be -1, -2. Aha! My vertex here is -1, 0. So if I go here at -1, 0. Ah! Okay, so I did 0 times 3 is 0, and then I went, oh, 0 minus 2 is 0. Aha! It should be -2. So -1, -2. All right, let's try that. Now it makes sense. All right, so that would be the graph. All right, I'll hit pause and keep going. All right, this is what you should have gotten if you made all the correct, well, okay, provided I didn't make any mistakes. Remember, I'm human too. Okay, so right here, I made a mistake, but the key is that I caught it. So I realized something must have been wrong, so I checked it. Should it be rising 1, 3, running 1, rising 3, running 1. All right. I think this should really help you prepare for the test tomorrow. Go home tonight, look at all your quizzes, review, and I'll see you tomorrow. Bye.